We will now solve logarithmic equations and more complicated exponential equations. Now that we know the definition of logarithms, it allows us to convert between logarithmic and exponential form, and that allows us to solve equations. So you can see in part A, B, and D, these are logarithmic equations. You can see the variable appears here as the argument in part A. Here it appears as the base, and here again this x appears as part of the argument. Now part C is here. This is an exponential equation. And if you look at this exponential equation, the method we've used so far for exponential equations is to write both sides with the same base. Well, there's no way to write e and 1/3 with the same base. So because we can't write them with the same base, we need a different method. And it turns out logarithms will actually allow us to solve these exponential equations as well. So let's look at part A. Log base 5 of x equals 3. So if we want to solve this, we've got to get that variable out of the argument. So right now it appears as the argument of the log. We've got to rewrite this using the definition of logarithm. So if we rewrite this, well, it's equivalent to 5 cubed equals x. Remember, the base of the logarithm is the base of the exponent. The log's always set equal to the exponent of 3, and that's going to be equal to our argument. And right there, we're done. We've isolated our variable. X equals 125. And you do want to plug your answers in, check them. If you put the 125 back in, you'd be taking log base 5 of 125. That's okay. Remember, we can't take log of a negative number, so just make sure you check these. So here's our answer, 125. Let's look at part B. Here our variable appears as the base of this logarithm. So if we want to solve this equation, we've got to get that x out of the base and isolate it. So the definition of log will here as well allow us to pull that x out of the base. So the equivalent form would be x cubed equals 1/8. So if you know the definition, if you know these rules, these equations are actually very quick. Logarithms don't take a whole lot of lines in your paper if you know the rules. So here I've got x cubed equals 1/8. So I just take the cube root of both sides to take the cubed off of that x, and then I have x equals 1/2. And if I plug my 1/2 back into my equation just to make sure it makes sense, I'd be taking log base 1/2. That's okay. Remember, we can't have negative bases and we can't have a base of 0. So just make sure that we plug that 1/2 back in there. We're okay. Okay, part C. Here is an exponential equation. Like we said, it's an exponential equation where we can't use the rule that we used in the last section where we write both sides with the same base. So logarithms will allow us to pull that variable out of the exponent. So if I write this in the equivalent logarithmic form, I'm going to have log base e, which we write as natural log, of 1/3 equals negative 2x. Remember, the base of the log, which is e here, is equal to the base of the exponent, e. The logarithm is always going to be equal to the exponent, so it's going to be equal to the negative 2x. And then we put the argument here. So then I just need to divide both sides by negative 2 to isolate the variable. So then we'll have x equals negative 1/2 natural log 1/3. So this is our exact answer. So you'll be asked to find exact answers and to approximate to a certain number of decimal places. So let's practice entering this in the calculator. So we want negative 1/2. And we've got our ln over here, natural log button. And it prompts us with the parentheses, so we'll enter the argument 1/3. And we get about 0.55. So the problem will tell you how many decimal places to round, but I'll just round it here to 2 decimal places, so it's approximately 0.55. So be prepared to give your answer both as exact and approximate. And now I'd like you guys to try D on your own, please.